These are the video notes for lesson 2.2 on point-slope form of a linear equation. So in 2.1 we hit the first form, which was slope-intercept, or y equals mx plus b, one you guys would definitely be familiar with from the past. And today we hit the other form, another form, which is point-slope. And the wording of the types of forms matches exactly what you're looking for when you want to go write those equations. So when it's slope-intercept, we want a slope and an intercept. When it's point-slope, we want a point and a slope. And then actually you can convert point slope into slope intercept, and I may do that for you guys a little bit later, but let's just get into the formatting of it and what it looks like. So the equation for point slope form reads like this: y minus y1 equals m times x minus x1. And the point would be what we call x1, y1, the slope, which we would call m. And essentially what you do is drop those things into the equation. Things you would want to leave is you definitely want to leave the y and the x. You should, in any equation that you're writing, all equations have y and x in them. So this should stay put, and this should stay put as a variable. But the y1, m, and x1, those are replaced. So you'll be given a point and given a slope. That would be the easiest version of this, where you just basically get to dive right in and plug them in. Then what we do with these equation writing problems is we tend to pull back on some of the stuff we give you and make you find some of it. So the way we can pull back is we can say, well, we're not going to give you the slope. Go find it. Then go write it in point slope. Or take it from a graph, or just kind of a variety there. So, but it can be as easy as here's the point and the slope, and you plug in. So we're going to operate off of that form and run through a bunch of examples and wrap it up here in a little bit. So name the point and the slope. So the first thing we're going to do is practice actually not writing, but identifying the parts from the equation. So when you guys look at these equations, if I take my point-slope form and I match it up over here, it's pretty clear what's what. So when I go to write my slope, m is equal to negative 2.4. When I go to write my coordinate, x comma y, which we would call my point would be 3 and 8. Now you notice in this first round, I just pulled them right out because it was y minus y1, so that means y1 had to be 8, and it was x minus x1, which means x1 had to be 3. A little bit of a change, we go to the second one. The second one actually is not in point slope form. So I'm going to do a little shuffling here and just add that 7 over to the other side so it looks more like a point slope form. Then again, what I'm trying to do is now match this equation to this one and grab the stuff out of it that I need, which again, pretty easy. It's all just kind of sitting there, but all of a sudden now we've got plus going on. So what you have to ask yourself is, if it's plus in the equation, how would that translate to the coordinate? And then we can work backwards a little bit and explain that too. The slope, again, easy enough. That's just sitting there staring at you on the page. That's our 12.3. Our coordinate, our point, x comma y. Well, here's the thing. If it's plus 7, how did it become plus 7 when this says minus? And for that to happen, or plus 4, it had to be negative. So negative 4, negative 7. Now, if you want to prove it to yourself, like how is that happening, let me show you quick, and then we'll talk about kind of a quick shortcut that'll make that pretty easy for you guys. Let's say that was my original point, and I asked you to plug it in. Here's how it would go if I plugged it in. I would go y minus, and then I'd put in my negative 7. Slope. Then I would go x minus, and I would put in my negative 4. And you guys should know from your basic algebra and even pre-algebra that minus and minus is a plus. So now there's kind of another way to think about this. This is something that we need to think what happens when we go from equation to point or vice versa. And the easy way to keep this straight is to remember that from the equation to the point that you're going to write out, the signs actually change. Because you may look at this and go, well, that's actually minus 8, minus 3 when I look at it, but it's positive, positive here. So from equation to coordinate, sign change. And same thing going on here. When I look at my equation, it's plus, plus, but when I go to my coordinate, it's minus, minus. So the reasoning behind it is definitely what's happening here, but I think kind of a shortcut is eventually we just realize that when we go from one to the other, we have a sign change. And that works going the other way, which I'll show you in a little bit. So that's an important point to remember. So here is going the other direction. Now here, this would be the easiest of all your problems. Give you a point, give you a slope, and just plug them in, drop them into the equation. The point you're given would be considered our x1, y1. Again, as a reminder, your equation always has to have an x and a y in it somewhere. Like what stays put, what does not get replaced, which would be that. Otherwise, here we go. So now I'm going to write it out this time with the signs laid out, and then we'll talk about again the shortcut way of thinking about it. So if I go minus a negative 6, my slope is negative 2, and then x minus 4. And here's where the minus and a minus become a plus. Now, if you compare the original coordinate to the black equation, let me just kind of grab and move some stuff here quick for you guys. As I go from coordinate to equation, signs changed. It's positive 4 in the coordinate, it's minus 4 in the equation. It's negative 6 in the coordinate, it's positive 6 in the equation. So, while you can definitely do this work, this might be something you decided you're just going to cut out and go, you know what, I don't need to do the minus part of this on paper. I just understand at this point that here's where I'm going to end up. Now, as a side thought, we could turn this back into y equals mx plus b, so I'm going to show you how that works. In the future, you may be asked to convert back and forth. So right now we're in point slope, and if you remember y equals mx plus b, which is slope intercept, and that's just a little bit of simple algebra. So all I would do to pull that off is, what's this here? I'm going to, whoops. Give me just one sec to regroup, and I'm going to clone that too. Hang on, everybody. All right, so we'll circle this one as our final answer here. But anyway, to convert, go ahead and distribute. So multiply that negative 2 in, so that'd be negative 2x plus 8, y plus 6, subtract 6 to the other side. We're talking about some algebra 1 now. And there would be slope-intercept form with the same information. So you can definitely change over, but for today anyway, in today's assignment, for the most part, you'll just be working everything in point slope. Okay, let's just try a few more here, and then, like I said, we'll wrap it up. This is going to be a pretty short set of notes. So this is the kind of problem where we would pull back stuff from you guys a little bit, saying, we're not going to give you everything you need where you can just dump it into the equation and call it good. We're giving you 2 points and saying, come up with the equation of a line that passes through it, write it in point slope, and maybe we'll even do a little bit of conversion just to practice that. What is missing from all this is I've got more than enough points. I have 2 points, right? But I don't have the slope. Where's the m? But we should know how to calculate that. This is not a new concept for you guys. So we're going to go difference in the y's over difference in the x's. Which one you call the first and second point doesn't really make a difference. I'm just going to go like in order across the page. So when I go to plug in and do my slope, negative 1 minus 7, negative 3 minus 5, that's negative 8 over negative 8, which is actually a slope of 1. Now, when you guys go to write your equations, the question that usually pops up for most students is, well, which point should I use? And actually, it doesn't make a difference. You can use either one. They both will give you the correct equation. So when you guys are doing the homework, the online homework, if you've already done it, you might have noticed that it asks you to write both possible equations, okay, because there really are 2 possibilities. So let's say I use my slope of 1 and a coordinate of 5, 7. And then my second version, we're going to say the slope doesn't change, right? But I'm going to use the other coordinate and just come up with 2 versions. So here we go. Y minus y equals m, which is 1. Now, when your m is a 1, it doesn't really need to be there. I'm going to write it in for now just so like you guys are clear what's happening, but then x minus my x. And over here, now y minus a minus is plus, so maybe I stop writing that, or I just know that sign changes at this point. And then again, a slope of 1, and then x minus my x, so minus a minus is plus. In the final version of this, the 1s don't need to be there. When you have nothing sitting in front of your parentheses, it's implied that it's a 1. So we're good. So there's my 2 versions. And they're both correct. Now, what I'm going to show you what happens here is we're going to multiply them, or change them into slope-intercept, just for one reason to kind of prove to you that they are actually the same equation, even though I'm using a different point. So let's do that conversion. We would actually really just have y minus 7 equals x minus 5. I drop that parentheses off, which I can do, because there's no number to distribute in besides a 1, and then add my 7 to the other side. Now it's in slope-intercept. Go over here and do the same thing. Drop the parentheses off, because they don't need to be there at that point, and then subtract 1 to the other side, and slope-intercept, and what do you know, right? So the idea of having 2 different versions of the equation is just because you can choose either point. Ultimately, it actually is the same equation. If we graph these 2, they would see identical, same exact line. Okay, so the idea of this problem is that I have to do a little upfront work, do a little slope calculation, then I can write one of the two. All right, one more to go. Actually, two more to go. So pull back a little bit from just throwing the stuff at you, go from a graph. Well, okay, so I got to count the slope. Easy enough to do. So if I count my slope, now slope is counted from a graph left to right like you read a sentence across the page. So if I'm going to have to go from one point to the next, then I got to figure out what's my count. So if I'm starting here, the first movement is going to be down, and that's down 4, and then over, and that's 5. You always go up or down and to the right, because reading a sentence left to right, reading your graph left to right, the same idea. So I move left to right across the page. So not this was a huge, extra step. I just had to take a second and there we go. Now again, there are two versions of this depending on which point I use. So I'll write both of them. Let's say I use -2, 3, or the same slope and using 3, 1. 3, -1, excuse me. All right, so let's say I'm doing it with -2, 3, y minus 3, -4/5 m, x minus a minus is plus, or I just keep reminding myself that from coordinate to equation I have a sign change. I'd use the same slope but different point, so this would be y minus a minus plus, -4/5 x minus 3. And again, if I was to convert those over into slope-intercept, mx plus b, they would both produce exactly the same equation. Okay, so, you guys won't always have to write 2, by the way. Eventually it'll just be like, pick one, okay? But there's the concept. And then finally, just some practice. So this is a point where if you guys were with me and we're doing this together, I would say pause the video or maybe breakout rooms or whatever. So assume I pause for a second. Let's pretend I pause. And now I come back and plug them in and check it out. Some things that are a little bit unique here is that there is 0 in some places in the problem. So the first one's standard, just drop it in. You notice again from coordinate to equation, sign change. When you go to number 2, y minus 0. Now typically when 0 is plugged into something, we let it disappear. But if you're asked to write it in point slope, then that's point slope form, so I'm leaving it. And then the last one, 0 slope. Again, notice the sign change, coordinate to equation. So -9 becomes positive, 6 becomes negative. And again, if I plugged in 0 and 0 multiplied by something, that would still be 0. So that should really zero out the entire right-hand side. But because we're asked to leave it in point slope form, in this case, we're just going to tell you guys to leave it like that. Okay, that's it for the 2.2 notes on point slope. Hope that gives you a good well-rounded picture of everything. That'll do it.